All right, we're going to start by going over this problem, which is number of deer in a wildlife sanctuary. It's number one on one of the worksheets, and then we'll go through all the problems on this worksheet first. All right, so in the year 2000, and then if I jump down here, t equals 0 means 2000. So when t equals 0, we know that there are 500 deer. And then by 2003, which is time 3, we know that it had increased to 650, and that is our maximum. And then 6 years later, which would have been when t equals 9, we're at our minimum, which is 350 deer. Okay, and that is our min. So if I do a quick sketch of this, here's 500. I go 1, 2, 3, up, 1, 2, 3, 4, 5, 6, down, and then you can see that that is my sinusoid that I have to deal with here. So I need to find my normal things here, my amplitude, my period, my midline, and my phase shift. So because we start at our midline here, there is no phase shift. The midline would be this 500, so y equals 500. The amplitude, if I go from 500 up to 650, that's 150. And then the period, well, if I know that this time from here to here is 3, then I can see that my total period is going to be 4 times 3, which is 12. From this, I can figure out that my b is, so 2 pi over b equals 12, which means that b equals pi over 6. And there's no phase shift, so I don't have to find a c. So then I can write my sine function. It goes up first, so it's a positive sine function. Amplitude is 150. Sine of pi over 6x, no c, plus 500. And that is number 1. All right, if you have questions about that, you can talk to me in the chat, which nobody does. All right, second one. The moon problem. All right, so we know that half of the moon is visible on April 2nd. So t equals 1 means April 1st. T equals 20 equals, so this is t equals 2. We're at 50%. And then at t equals 14, we're back at 50%. Okay, and there was more visible on the 3rd. So what we have is, if I were to sketch this out a little bit, here's 1, 2, 3, that at t equals 2, I'm there, and then I go up. And so if I go all the way 3, there, I'm back at 50%. So I'm going to go up somewhere and then down. How are we supposed to find what that is? Well, this is about the moon being illuminated, and hopefully you guys all recognize that at some point there is a full moon, which means 100%. Okay? And then also as it goes down, eventually there's a new moon, which is 0%. Okay, so from this we should be able to find our amplitude, our period, our phase shift, and our midline. Okay, so the midline is going to be 50% because that's the middle. And we're just going to think of that as 50. And the you could have also done 0.5, and I would not have marked that wrong. The amplitude then is also going to be 50 because we go up to 100% or down to 0. The period, well, I know that it takes 12 days to go from the 2nd to the 14th. This is 12. So to get the whole way back to where I started, it's going to be another 12. The period here is 24 days. And the phase shift, well, if this is at 2, I've moved over to the right 2. So now I can find my b, which is going to be, so 2 pi over b equals 24. So multiply by b, divide by 2, divide by 24, I get b over 12. I'm sorry, pi over 12. And then c over b, c over pi over 12 equals 2 is going to give me pi over 6. And this is a sign. It's going in the positive direction first, so it's a positive sign. 50 sine of pi over 12 x. It's moving to the right, which means that I have to have a negative pi over 6 plus 50. And again, you could have had 0.5 here and 0.5 here as well. All right, that is the moon problem. Moving on to the swing problem. All right, so this girl is allowed to be in the parks because it's before the pandemic. Her dad swings her by pulling her back 4 feet. All right, so what we have, let's draw a quick picture here. All right, so here's the girl on the swing. Okay. And we have that, pulls her back 4 feet. Okay. So, what do we know here? We know that at time 0, her position is, we'll call it y, is -4. And it takes her, time it takes to swing, forward and back to her original position is 3 seconds. So at time 3, she is back to her start. Write a function that represents the distance from the center of her swing. Okay, so is that enough information? Well, let's draw a quick sketch and see. We're here, and then 3 seconds later, we're back here. Well, hopefully you know how swings work, and you know that when she swings forward, she's going to swing forward just about 4 feet from the center. So if this is 4, halfway, she's also going to be up to 4. And if this is modeled by a sinusoid, which it is, because pendulums are sinusoids, it's going to look like that. All right, so we have the period is going to be 3 seconds. We have the midline is just the x-axis. We have the amplitude is 4. And there's no, well, depending on where you want to start this now, if you wanted to pick this point right here and think of it as a sine graph, you could. You'd have to figure out where that is and figure out a phase shift. Or you could just recognize that this is a negative cosine graph that starts at its minimum. And so we have that our A is going to be 4 because our amplitude is 4. Our period is 3 seconds, and 2 pi over b equals 3 means that b is going to equal, so we multiply by b, divide by 3, 2 pi over 3. And then our midline was 0, y equals 0. And again, make sure you say y equals for the midline. And the phase shift is none. So c is 0. And then we can put this all together and say that we have y equals -4 cosine 2 pi over 3 x, or t. I guess I should be using t if I'm saying t equals 0. Nope, no, there was a c. No, there wasn't. There's no c or d. So it's just that. All right. We're just swinging right through these. All right. Blood pressure. Okay, so got a nice joke there. All right. Blood pressure can be modeled using a sinusoid. When you get a reading, the top number, called the systolic pressure, represents the maximum pressure. That happens when the heart contracts. Bottom number is the diastolic. Okay. And the pulse tells you how many times per minute the heart beats. Okay, so what we have is that the maximum is 160 and the minimum is 90, and the pulse rate is 80 beats per minute. Okay, so that is all the information that we have. So what we're going to do is we're going to assume that this starts at time 0, that we're at our max, 160. And then somewhere at a time later, we are going to be at our min, which is 90. So from just that information there, we should be able to figure out where our midline is, because it's going to be halfway between 160 and 90. So that is, well, the whole distance is 70. So I need to go down 35 and up 35. And so that's going to put us right at 125. So our midline is y equals 125. And our amplitude is 35. So now we just need to think about, the x values here, the start and the end. So if we start here, if we draw our sinusoid, it's going to look like that. We could think this starting at its maximum is a positive cosine, which means there's going to be no phase shift. And so now it's just a matter of figuring out the period. If there are 80 beats per minute, that means that there is 1 beat for every 1/80th of a minute. Probably makes more sense to do this in seconds, though. So 1 beat, how do I want to write that? Not like that, not at all like that. So each beat, 1 beat, is equal to 1/80th of a minute, or 1 beat is equal to 1/80th times 60 seconds, which is 3/4 of a second. So the time it takes to get from here and complete 1 beat is 3/4 of a second. So if I extend this back up to a maximum, that's going to be 3/4. So the period here is 3/4 of a second. Okay, so if I do 2 pi over b equals 3/4, 2 pi over multiply both sides by b, I get that. Divide both sides by 3/4. I already had a line there. Those cancel. And 2 pi divided by 3/4. A little help from Mr. 1. And I get 8 pi. B equals 8 pi over 3. And so now I can put this all together. It's a positive cosine. The amplitude is 35. Cosine 8 pi over 3 x. Don't forget your x there like I just did. There's no phase shift, so there's no c. Midline is 125. So that is the blood pressure. And this is why it's a cosine, so that's why he didn't see the signs, I guess. All right. In the next video, I will do the other worksheet.